All right, welcome back, AP Human Geography students, to another lecture. This one focused on our population unit. Well, we're going to look at some of the differences between population distribution and population density, as well as talk about a couple different ways to think about the distribution and density of populations at various scales. Today, there's about 7.8 billion people on the planet, a number that the Earth has never come close to supporting at a time before. And we're going to look at a lot of the effects of that population growth and some of the things that have been done to try and manage it or even reduce it in future lectures. In a real general and kind of basic sense, we can talk about the distribution of people on Earth in a couple of the following ways. That today, and for the first time ever, over the last couple decades, more than half of the Earth, about 55% of all people on Earth, live in an urban environment. That means in or near cities, as opposed to a rural environment where they are more in a kind of agricultural farm setting or something like that. About 90% of the Earth's population lives north of the equator. And if you study a map, a big part of that has to do with the majority of the landmass being north of the equator is one major part of it. About 90% of the people on Earth are living on about just 20% of the Earth's land. And at least part of that idea there is going to be the focus of some of this lecture. About 80% of the Earth's population lives at less than about 500 meters elevation, right? So in relatively lower elevations. That too will be something that we discuss a little bit. And about 2/3 of the Earth's population live within about 500 kilometers or 250 or so miles of an ocean, right? Have a kind of coastal existence. And that's been typical throughout human history. This map, I believe, comes from your textbook and breaks down the distribution of people on the Earth into the billions, right? Basically, every different color, each grouping or chunk of territory on this map reflects about 1 billion people. So you can see China has been cut into several pieces, right? And either paired with North Korea, South Korea, and Japan, or with Southeast Asia, or the northwestern parts of China grouped with other parts of Central Asia, right? Russia, the Middle East, and Europe make up about 1 billion people. All of North and South America, together with Australia and New Zealand, add up to about 1 billion people. There is about 1 billion people currently living in Africa, and about 1 billion people in what we call South Asia, right? India, Bangladesh, Myanmar, Sri Lanka. Another way of visualizing this, and I'll ask you to think about what type of thematic map you're looking at here. But this is a cartogram that reflects population throughout the world and how it's distributed, or where it's distributed, rather. This final map is one that shows us at the same time both the distribution of populations across the globe and the density of those populations. Population distribution is the pattern of human settlement across the Earth. Creating a map of distribution like this would let us see places that are crowded or sparse or even empty. Similar, but a little bit different, is population density, which is specifically measuring how crowded a place is by comparing the number of people there to the amount of available land for them to live on. On this map, you can see the areas that are sort of darkest, almost that purple color, are with the highest concentrations of people, right? About 1,000 people per square kilometer, or in some cases, we'll see much more than that, actually. And some places like Siberia or the Sahara or big parts of, northern Canada, Australia, a lot of the deserts of the world or the rainforest with fewer than one person, right? Basically empty. And we'll talk about what exactly those parts of the Earth are known as to geographers. This kind of information and data on population density and distribution is still very useful to people for things like drawing electoral boundaries, deciding where to develop new housing, depending on the scale with which you are examining it. The world reached its first 1 billion people around the time of the year 1800. And in the 200 years since, it now contains about 7 times more people than it did 200 years ago. While the population densities of the globe have increased significantly, the distribution of those populations has remained basically the same, right? For example, Eastern Asia or China was one of the most populated parts of the world in 1800 and remains so today. A lot of these places that are the great population agglomerations or concentrations of people in the world were so historically as well, okay? So on this slide here, you see some of the same places that you will see discussed in your reading. East Asia, which contains about 1.5 billion people and includes China, the Koreas, and Japan. South Asia, which contains a similar amount of people, over 1.5 billion people. It's mostly kind of people living in a rural situation, but includes places like India, Bangladesh, Sri Lanka, Myanmar. Europe, which doesn't quite reach 1 billion people, but has, somewhere upwards of 750 to 800 million people living within Europe, mostly in an urban sort of situation. And Southeast Asia, which is includes, but is not limited to, right, the countries of Vietnam or Singapore, Cambodia, Laos, Indonesia, etc. There are some emerging population agglomerations, right? Places that historically might not have been major concentrations of human beings in the past, but are emerging as such today, right? These would include the northeastern part of North America, all right? You can kind of think of the area from Boston to Washington, D.C., maybe even over to Chicago and up into parts of Quebec in Canada, would all be kind of contained in this emerging population agglomeration. Something like 2% of the world's population lives within that area. Another spot would be in West Africa, particularly around the country of Nigeria, the most populated country in Africa. Oftentimes, these distributions and concentrations of people are near particular things, right? It is their situation that gives rise to these concentrations. Often you will see these populations near trade routes, whether those are coastal ports or highways. Our own Las Vegas exists on the I-15, right? And that's part of what allows us to exist and maintain ourselves here, is the high traffic we get from that trade route, that highway, to resupply ourselves and make it easy for tourists and visitors to come visit us. Other things that might draw large concentrations of people could be areas of political significance, right? Certain capitals, or cultural and religious significance, like certain holy sites. In addition, each of these can cause population distributions to change, right? The building of new roads, new highways, new military bases, or the expansion of certain groups like the Mormons or the Amish historically in the United States, as they escaped various forms of persecution. All these things can change population distributions from what they currently are. Depending on where you are in the world, the kinds of features that are attracting these concentrations of people might vary, right? In a very general sense, in East Asia and South Asia, largely you find these concentrations of people along physical features, like the Yellow or Yangtze rivers in East Asia, the Indus and Ganges rivers in South Asia or within India and Pakistan. In Europe, though, because a lot of the large major cities there are newer historically, it's a lot more likely that you're going to find those cities and concentrations of people around certain concentrations of resources like coal or oil. In your reading guide, you should be marking these population agglomerations, annotating them, and beginning to study where these agglomerations are. It's also important to take note that even though concentrations are different sort of throughout the world here, people are also finding themselves in different kinds of environments, regardless of the concentration of population, right? So again, I would encourage you to pay attention to the amount of people in those areas that are living in an urban or rural situation. For the Northeast, North American emerging agglomeration, that's one of the most urban spots in the world, right? Something like 95% of the population around Boston, Washington, Chicago, and up into Canada are in an urban setting, right? In Europe, this approaches upwards of 80% nowadays. And in more rural areas like East Asia, Southeast Asia, West Africa, where over half the population is still in a more rural environment. The ecumean and non-ecumean are vocabulary terms that describes basically where a lot of people live and where relatively few people live. The ecumean refers to the inhabited areas and parts of the earth. All right. And there's a couple consistencies you find throughout what we call the ecumean, right? The place where people live. One of those things is that generally it is within the mid-latitudes, right? The area sort of between 30 degrees and 60 degrees north or south of the equator, right? So not quite around the equator, but a little bit above and below the Arctic areas. These mid-latitude areas, it's typically going to be because of climate, right? Because it's a little bit more mild in those areas versus the kind of sweltery, warm heat of the equator or the frigid, kind of colder parts of the Arctic Circle areas. Low-lying areas, places at a low elevation, are popular typically because they have better soils for raising crops than high altitude areas or upland areas. Also, lowland areas are usually near oceans, which also serve as an alternate source of food, a mode of transportation, and a way that the ocean itself kind of regulates temperature, right? Makes it a little cooler in the summertime, a little warmer in the wintertime, has a moderating effect. Fresh water and other resources are typical to what makes the ecumean, right? Water is a necessary basic for survival and agriculture, and other resources, like we mentioned, coal or oil or timber even, might attract concentrations of people to make it easier to harvest that resource. Now, one thing that comes up as we talk about maybe low-lying areas, differences in elevation, and how that might attract people or not, is to think about that in terms of scale, right? At the global scale, humans generally avoid high-altitude areas like the Himalayas. It's not unheard of to find people living up there, but it is cold, agriculture is very difficult, the air is thin, and it's not densely populated. But at the city scale, right? When you go to a much larger, more zoomed in scale, at the city level, oftentimes you find people do seek out higher elevations, right? That wealthier people will try to live in the hilltops and so on that surround communities because of the views that they give, maybe because it provides greater security from things like floods and so on. So again, the scale at which we're examining population is going to lead us to some different conclusions on what people choose to do, right? At the global versus the local scale. Now, the non-ecumean does not necessarily mean that people don't live there. It just means that people are a lot less likely to live there, right? That you're going to find much lower concentrations of human beings there. For example, the Inuit in North America live in areas that are generally too cold, right? The Andes Mountains of South America have more people than the relatively low-lying Amazonian tropics. That's generally because the mountains are not as hot or humid. They avoid a lot of the diseases of the tropics at higher elevations. And in those mountains, in the Andes in particular, the volcanic soil of those mountains and valleys provide a more nutrient-rich environment for agriculture than tropical soils. And so they can generally kind of support higher populations in those higher elevations. But in general, the places that we're going to describe as the non-ecumene, the places that aren't inhabited very much by people, are places that are too wet, swamps, things like that, too dry, so deserts, but also remember that deserts have to do with precipitation. So someplace like Antarctica or the Arctic might also count as desert, dry environments, right? Places that are too cold or at too high of elevations, right? Do not confuse dry places with hot places. We live in a place that is hot, but not too dry for us to live here, right? We live near a river and a lake. That is why we are able to support populations at this site. But that is what we would describe as the non-ecumene, right? The wet, dry, cold, or high areas where people avoid living. The last part of this lecture is going to examine a couple different kinds of population density, right? Particular kinds of density that help us to answer certain questions about a population in a given area. By using more specific measures of density, we can gain different insights about a country, for example, right? Such as its level of development, maybe the type of economy it has in place, or how people within that economy are working, right? Where they're mostly employed. It can give us clues about the population growth, the health and welfare of those people, how internationally dependent that country might be, and we'll explain some of this here in the following slides. The three types of population density that we're going to examine are arithmetic density, physiological density, and agricultural density. So starting with arithmetic density, which is the simplest of the ones that we will look at, and it's often called crude density because it's such a crude number, right? It's hard to kind of extract a lot of information from it. But arithmetic density can be calculated by dividing the total number of people in a country or area by the total land area. All right, so if we did this for the United States, took the total population of the USA, divided it by the total land area of the USA, you get about 83.6 people per square mile, right? About 84 people per square mile. So does that mean there's exactly 84 people for every square mile in the United States? No, it does not mean that. And that is why this is sort of crude. We know from some of the slides we looked at before that the density, the concentration of those people is going to vary widely depending on where you're at. Arithmetic density gives us kind of a where the people of the earth are, right? But doesn't really reflect why they might be concentrated in certain areas. Doesn't tell us a lot about what areas will continue to grow or might be straining their resources or approaching their carrying capacity or overpopulation. So in that sense, it is crude. It's not as useful as some of the other measures we're going to look at here, such as physiological density. Now, physiological density goes by another name as well. It is sometimes called nutritional density because it's based in part on the amount of farmland in a country. So physiological density is calculated in this way. You take the number of people in a country divided by the area of arable land, or the amount of farmland, right? Land which is suitable for agriculture. So I tell students this is people over farmland, all right? That's kind of the equation for physiological density. And because it's related to food, that makes sense why we call it nutritional density. But this is a much more meaningful number, okay? It can be very useful for estimating a region's carrying capacity, all right, or the amount of people it can support before it starts to strain or deteriorate the surrounding environment by excessively kind of drawing resources from it. Generally, or basically always, physiological density will always be higher than arithmetic density, unless the entire country was considered arable, but there's no examples of that, especially as more and more countries urbanize and arable land is kind of, paved over with concrete and asphalt. What we can see, though, is that a country with a high physiological density, someplace, again, maybe like Bangladesh or like Egypt or the Netherlands, this indicates that a country needs high crop yields to reliably supply its own food, right? It means that a lot of people in that country are dependent on each acre of arable land or each, whatever amount of land. A large difference between the arithmetic densities and physiological density means that only a small percentage of the total land area is able to produce food, right? Egypt is a great example of this. You can see Egypt in red on this map, right? Showing that it has more than 2,000 people reliant on each square kilometer of farmland. And when you look at a remote sensing image of Egypt, you can see why that is, right? This image, taken by remote sensing satellites of the Nile River in Egypt, notice a couple things that beyond the kind of wide delta towards the north of Egypt there, most of the habitable and arable parts of Egypt are one and the same, right? They're concentrated along the banks of the river, extending just a small distance to either side before it gives way to this very harsh, inhospitable desert that we would consider a part of the non-ecumene. Somewhere close to something like 98% of Egyptians are living on just about 3% of Egypt's total land area. The entire country is dependent on similar stretches of land for both living and farming, which creates other issues we'll explore in later units. But in a nutshell, you have problems like housing development and urban growth eating up some of the prime arable land of a region, right? Pushing the physiological density up even higher. So development can kind of come into this as well, right? How wealthy or well off a country is plays an important role when they have a very high physiological density. For example, Japan has a similar physiological density to Egypt. Although in Japan, they're much more able to sort of supplement their food supply with fishing, and Japan, being much wealthier, has an easier time paying to just import food from countries that produce excess amounts of it. And that's a way that a country being an MDC makes it a little bit easier to deal with problems of physiological density. The final form of density we're going to examine here is agricultural density. All right, agricultural density is calculated by looking at the number of farmers relative to the total amount of arable land or land suitable for agriculture. So arithmetic density, total amount of people over total amount of land. Physiological density, total amount of people over farmland. Agricultural density's equation would be the total amount of farmers over farmland. Well, what's useful about agricultural density is that it's very indicative of the efficiency of a country's farmers, right? How effective they are at producing food, right? How much food, or really kind of acreage, each farmer is going to be able to handle on their own. And what we see generally is that, again, due to levels of economic development, MDCs tend to have much lower agricultural densities because of the availability of technological assistance for their farmers, right? Things like tractors or seed drills, reaping machines, crop sprayers, GMO seeds and fertilizers, etc. In LDCs, in less developed countries, the agricultural density tends to be much higher because farmers often cannot afford that modern technology and are so left much more dependent on human labor to help them work their land, which pumps the agricultural density up a lot higher and has a lot more of your country engaged in the practice of agriculture than you would find in MDCs. When we get to our agricultural unit, we will discuss different types of agriculture that relate very much to this idea of physiological or agricultural density. We'll talk about intensive and extensive agriculture, right? Intensive agriculture tends to be on smaller plots of land, things like rice farming, right? Where the goal is to extract as much food from this area of land using all the intensive methods and techniques that you can, right? To farm with a kind of intensity to gain more food, right? To work the land harder. Extensive agriculture is kind of the opposite of that. Tends to take place on much larger plots of land. Things like ranching or herding or growing wheat or corn. These things that you do that you get more food of by simply bringing more land into production, right? Well, depending on the availability of farmland, your country might be pushed towards one style or the other of agriculture, right? Maybe a lot less extensive agriculture in a country like Bangladesh or Japan than you would see in places with relatively lots of farmland like the United States. This can also be a good, what we'll refer to as an indicator of development, right? A good way to kind of judge how relatively, right, economically developed or not a country might be. Because again, agricultural density is in part going to reflect the access to technology and funds and subsidies that farmers in these countries have, right? So on this choropleth map, the countries that are in green, for the most part, are LDCs, right? Or somewhere in the middle of the kind of economic development spectrum. And the countries that are in kind of the beige yellow here are mostly MDCs, right? Are kind of generally wealthier countries or places that maybe have a lot more farmland and access to technology. And so to conclude, when you were able to compare some of these various densities across different countries, you can start to draw certain conclusions about them based on those numbers alone, all right? For example, if you look at the bottom of this chart here and look at the countries of the Netherlands and Bangladesh, you will see that they have relatively similar physiological densities, all right? Bangladesh's population is much higher than the Netherlands, but they also have a lot more arable land, almost, twice as much. And so they end up with a similar physiological density. But if you compare the agricultural densities, that's where you see the real difference start to emerge and where we can see the value in calculating these different numbers here. The agricultural densities are so different, right? In the Netherlands, there's something like 23 farmers per square kilometer of farmland. In Bangladesh, it's 472 farmers per square kilometer of farmland. This is a direct reflection of very different levels of economic development. The Netherlands is much wealthier, and so its farmers are assisted by all the benefits of modern technology, government subsidies, etc., that the farmers in Bangladesh lack, okay? And so a much higher percentage of people in general are going to be employed in the industry or economic sector of agriculture in Bangladesh, which means there's fewer of those people to do jobs that might create more wealth for your country in general. And the opposite is true in the Netherlands, where relatively few people end up as farmers producing food for their own country, right? Just 3% of the country of Netherlands has to be employed in agriculture, and that is enough to feed the country. So that concludes the first lecture of the population unit, where we looked at the various forms of population density, examined some of the world's population distribution in its various population agglomerations, and talked about some of the ways that scale plays a role in human population around the planet. Thank you guys, and talk to you again soon.